3D printed coal loads. I've been experimenting with attempting to print fairly representative coal loads for wagons. I think I've got a reasonable amount of success. I think I mentioned I like to prototype in white PLA because to my eyesight it shows the details better. It may not be the case for the camera. Come on, focus. But I've developed a method, first of all, of printing quite a complex rough surface, and secondly of giving it a profile. And yes, I'm afraid there's quite a lot of stringing on this print, because the surface consists of a lot of individual points. All these lumps of coal come up to a point. But it is the perfect stringing test for a 3D printer. I think I mentioned before that I prefer to use Openscad as my development tool of choice, and again, because I'm a retired software engineer, and Openscad allows me to write scripts to model the 3D objects that I'm trying to produce. I would hate to try to model multiple lumps of coal without the use of a scripting language. Doing it individually would take ages. However, now I'll be providing the code for these, the Openscad code for these loads on GitHub just as soon as I get my account set up, and the rest of this video is going to be a bit software oriented because it's going to be showing how to develop the Openscad software. And so if you've got this far and you want to dip out, that's fine. This is the end product. If you'd like to see how I actually developed these, stick around and I'll walk you through the software. Other than that, see you later. Okay, so here we are back at Openscad, and one of the challenges of developing a 3D model for a coal load is that it consists of a whole pile of random shapes, lumps of coal, and to do that individually would take forever. So what I've done is I've had a look at the work of Thomas Nesrovenal. I hope I haven't pronounced that wrong, and I'll give a link to his random crystals work, and taking that code and then multiplying it by a number to provide what we see in front of us, a field of random crystals. In this case, I've just defined it as a flat bed. Again, I'll make this code available on GitHub once I get the account set up. And to let you know roughly what I'm doing here, I'm defining a rough shape, which is a field of these crystals, which is slightly larger than the size of the wagon that they're intended to go into, and then I'm removing the bits that don't fit within the side of the wagon, and the end result is, in this case, a flat load of coal, which doesn't look very realistic just for the moment. So I've also defined a function here called profile, which allows me to show either a flat load, or here we have one which is slightly inclined. Here we have one which is curved, but only in the length of the load. From now on it gets a bit more complicated. Here's one which is curved in both dimensions, both along and across. Doesn't show very well, but trust me. And then finally, you see, if I could type it would help. Finally, here we have three loads of coal, or 3 piles of coal in one wagon. You can see that these are exhibiting big flat areas. So one of the issues is, the taller we make the crystals, the more likely they are to show these large flat areas exposed. So let's go back to just a single pile. Something I didn't explain on the log loads video. Every time I save this model, because I'm using randomization within the design of the model, I get a slightly different coal load, and the same thing applies to the log loads. And just a final word on the design of these. I'd love to say I used artificial intelligence, quantum mechanics, to develop the profile settings to give the normal to give the load contours. But actually, no, I did it by trial and error. The prints, again, on my Creality Ender 3 V2 take about 50 minutes to an hour to print. Frankly, there are much quicker ways, much easier ways of producing a coal load. You know, even smashing a piece of coal and sprinkling that on top of some base structure. Question is, where do you get the coal from these days? I think I still have a piece of coal that my great uncle acquired when he went to see the Titanic being launched. But that's a story for another day. So thank you for watching. If you got this far, that's great. Hopefully I'll be back again sometime soon with another video. All the best. Bye.